In this example, we're going to take a look at a more tangible example of a column space at work. So in this example, we are posing the question, is the vector b equals 1, 2, negative 3 in the column space of matrix A, which has columns 1, negative 1, 2, 3, 1, 0, and 0, 0, 1. So the question being posed here is, if I take a constant times 1, negative 1, 2, plus another constant, C2, times 3, 1, 0, plus another constant times 0, 0, 1, can I get this to be equal to the vector 1, 2, negative 3? Now, in order to do so, normally what we would do for this is set up a matrix where each of the columns of the matrix represents the three vectors in question, and then we'll augment it with whatever we're setting it equal to. You'll notice that there is a slightly shorter way of doing this, which is to simply take the original matrix A and augment with B. So in this regard, very much what we have set up is it true that we can express A times C as being equal to B, where C would be the column matrix of C1, C2, and C3. Now, in order to solve this mystery, we'll need to take this down to reduced row echelon form. As such, we'll grab our calculator and input the matrix exactly as is. We'll edit ourselves a 3 by 4. First row, 1, 3, 0, 1. Second row, negative 1, 1, 0, 2. Third row, 2, 0, 1, negative 3. And then we'll just check to make sure that everything got copied in correctly. 1, 3, 0, 1, negative 1, 1, 0, 2, and 2, 0, 1, negative 3. We'll ask the calculator to take this down to reduced row echelon form, matrix A, and it looks like it is possible as we are getting a consistent system. We'll convert everything to a fraction because fractions are just far superior to decimals. Sorry, not sorry, engineering. We'll get the identity matrix to the left of the augment, which is indicative of a consistent system. And we have negative 5/4, 3/4, and negative 1/2. So to answer the question posed, is B in the column space of this matrix? The answer is yes, it is. And we'll point out that if we take negative 5/4 times the first column, 1, negative 1, 2, plus 3/4 times the second column, which is 3, 1, 0, minus 1/2 times the third column of 0, 0, 1, and this is where we're just going to double check. So this is negative 5/4 plus 9/4. Negative 5/4 plus 9/4 is 4/4. For the second entry, this will be positive 5/4 plus 3/4, that is 8/4, that is 2. This will be negative 5/2 plus 0 minus 1/2, that's negative 6/2, which is negative 3. So that does indeed verify that this linear combination is equal to the vector 1, 2, negative 3. Very good.